So these go to stop. Okay. So okay, I think that's all for NP chart. It's very similar to P chart. So just follow exactly this formula. So then I will show you continuing with the example here. Okay, so in this case, NP chart actually can also consider for variable and constant size. I think so. Okay. Now here we use constant size. Okay, so for NP chart, the steps are very similar to P chart. So we have a subgroup, total the sample size, 30 of them, and DI is the number of non-conforming reported, and then you calculate. So in this case, the sample size is the same 50. Then you need to use DI divided by 50. So you calculate for each subgroup. Okay. So, and after that, proceed with the control limit. How to calculate the control limit. Okay, so because the sample size is the same, so it's very simple, just like the formula in the slide. So it will be a straight line here. And then from there you can observe all are in control. So since the NP chart is a chart for the number of non-conforming, which is in integer value, then the upper and lower control limit you can modify to be 16 and 0. Just put in integer number because NP is a counting, right? Number of the size. So you can modify or you can use it as it is okay. But in case you want to put it in the round number, you can put it because it is a number NP, right? So the number of cases should be in integer. Okay, so this is different. This is another example. Okay, so you have 30 subgroup of samples with DI, the number of non-conforming reported, and then you need to calculate the P hat I. Okay, so the sample size is 50, so divide by 50, 12 over 50, you'll get everything. And then these are the formula. Apply, calculate the upper and lower control limit. For central line is N times P bar. Okay, so then you can plot already everything. So it's very simple. Okay, next one, we will move on with C chart. For count of non-conformity. So the non-conformities chart. So just now, P and NP are non-conforming chart. Now we move on to the non-conformity, which we call the Poisson distribution. Okay, so for non-conformity chart, control the count or the number of non-conformity within the product or service. So yeah, for the non-P and NP chart, we have a single smaller unit. So you measure one by one the unit of sample, either good or bad. While in the non-conformity chart, we try to measure the number of non-conformity because each unit is a larger unit which may consist of several elements. Okay, so an item is classified as a non-conforming unit whether it has one or many conformities. So you can apply C and U chart. So for C chart, it counts of the non-conformities. So the number of non-conformities, C chart. If you want to apply the U chart, it is based on the count of non-conformity per unit, per each unit. And then since these charts are based on the Poisson distribution, two conditions must be met. First, the average count of non-conformity must be much less than the total possible count of non-conformity. Okay, so average means the mean value, okay, must be smaller than the total possible number n. And then the second is the occurrences are independent. So each unit the occurrences of the non-conformity should be independent. So these are the control chart of non-conformity. The main purpose is determine the average quality level. This information gives the initial process capability. Then bring to the attention of the management any changes in the average. Then third one is to improve the product quality, which is ideas for quality improvement. Then fourth, to evaluate the quality performance of operating and management personnel. And then suggest places to use X-bar and out chart. Determine acceptance criteria of a product before shipment to the customer. These are possible conditions that you may apply the control chart for count of non-conformities. So C chart. Okay, so these are the steps. So the C chart is a graph of the number of defects per unit. The unit must be of the same metric size, height, length, or volume. So meaning that all should be indicated in the same measurement or into cm or so on, the same unit. Then the C chart is used to detect the non-random event in the life of a production process. So you want to observe the non-randomized event. So these are the formula to construct the control limits of the C chart. So as you can see, this one follow the Poisson distribution function, where Ci be the number of non-conformity in the I sample. You have 3 n samples. I is 1, 2, and so on. And then the non-distribution mean which is positive. So and then this is the mean, and the variance also equal to the mean, which is equal to mu. And again, we have the same formula, but now we just replace the target here with mu naught. Okay, if mu naught is unknown, we replace with C bar. C bar is sum of Ci divided by M. So as you can see, the formula is very simple. Okay, so these are the plot example. Okay. From there you can see observation 20 is our control, and then this one is which one? So they are our control. So, okay, so on back to the example C chart. So example, we have the number of non-conformity observed in 26 successive samples of 100 printed circuit boards given in the table below. Construct a control chart for non-conformities. So if the question asks you to construct the chart for non-conformities, so you should know you cannot apply P or NP, but you can use either U or C chart. So these are the total sample number. So total you have to pay for C bar. So is sum up all the number of defects and then divide by 26. So you get this number. And then straightforward, we can proceed to calculate the control limits. Okay, so the control limit is given. Variance equal to mean equal the value is C bar here, which is 19 point something. So you can see here. So this is variance. Okay, and then we take the square root of it to become sigma. Same value. Okay, so these are the upper and lower control limit. For central line, it represents the mean mu naught. So from the plot here, we observe 1 point, 2 point out of control. Then next, we need to investigate the reason behind. If they are due to assignable causes, then we remove them. So then we revise the control limit for the sample 6 and 20, which we already removed them. So we remove them means we have to calculate the C bar, the new one, which we sum up all the C, the defects, but exclude the 2 point, okay, 6 and 20. And then now we divide by 24 rather than 26. Okay, so total are 26, right? We exclude 2 samples. So now we have a new mu. Then we recalculate for the control limits. And from the plot here, all are within the 2 control limits. Okay, so we have an in control condition. Okay, think very simple. Do you have any questions so far? Okay. So we have totally 4 types of the attribute control chart. So the last one is the U chart. Okay, a graph of the average number of defects per unit is a U chart. The unit can be of different sizes. So for C chart, it only apply for a constant sample size. While for the U chart, you can consider fixed or variable sample size. Okay, and it shows the actual number of defects per standardized unit. Skill selected is continuous for the U chart. For the C chart is discrete. Then the subgroup size for U chart can vary. Okay, so as mentioned, for C chart is based on C equal to 1. Okay, so we no need to divide by something. So the each sample only have a sample size 1. Well, for U chart, the size can be different. The U chart is limited in that we do not know the location of the non-conformity. So later we will see it. So these are the formula where the mu naught is given and unknown. Okay, so different compared to the C chart. Here we need to divide by n, because it is per unit. Okay, so how to find the U bar? So U bar is obtained using this formula, sum up of Ui divided by n. Okay, so in this example, it is a plot of the U chart where varying. Is it varying? Should be varying. That does not mention the sample size, so should be okay. So this is per unit. Totally you have 24 subgroup for sample, so you get this. And then I think it's a constant sign, otherwise it is straight line, right? So we will go through other example. So in this example, we observe 5 successive data points below the central line. So the central line is here, is below the central line. So we need to investigate for the cause of sustained below mean performance. So although they are within the two control limits, but from here we can see there's a pattern. Continuously 5 points are below the mean for the central line. Therefore, we need to, it may signal the earlier out of control situation. Therefore, we need to investigate the reason behind. So this is a fixed size, constant size. Here is the example of variable sample size for U chart. So for variable sample size, we have no straight line anymore for the upper and lower control limits. And the formula to calculate for U bar is different. Just now we just divide by n, but now we have to divide by ni. I indicate the number of sample. So in which ni will be different across each sample. Okay. So I think that's all for U chart. We will go through the example. So in this example, we have a PC manufacturer which wishes to establish a control chart for non-conformities per unit. On the final assembly line, data on the number of non-conformities in 20 samples of 5 computers each are shown below. So this is a constant size with 5, n equal to 5. And we have the 20 subgroups of samples. Okay, so from here, we need to calculate for UI, but here is a constant sample size divided by 5. So UI is the non-conformity per unit. And then to calculate for U bar, we sum up all the UI, divide by sample size, total number subgroup 20. And then these are the formula to calculate for the control limits. So from the plot here, everything looks good in control. So, and this is the example of the variable sample size, in which the sample size for each sample are different. So from here you have ni, so sample 1 has n 13 sample, sample 2 and so on. You can see they are different in number. So to calculate for UI, you cannot divide by the same number. So you need to divide by ni instead. And then sigma also different due to the different sample size. So you need to calculate for each subgroup. Same with the upper and lower control limits, because they are different. So you need to calculate for each sample. Okay, so from there you may plot the U chart. So this is what you get. From here, we still observe the process is in control. Okay. So this is just okay. So just example how to calculate for the first sample. So how to calculate the mu, and then U bar and sigma. And then also upper and lower control limit. This is the formula which follow the as listed here. Okay, do you have any questions so far? I think it's much easier compared to the control chart for driver, right? So because the formula is simple, there are no need to show the number. Same for all the sample for four type of control chart. So assume I have this data I used to construct for the four type of control chart we learned just now. So these are the number of failure or defective, and these are the sample size. So meaning that I have a driver sample size. So I have a subgroup on 10 of them. And so to proceed, the set is very similar. We go to start, then control chart, attribute charts. So first I try with P chart. So I enter the driver of the defect, which is column 1. Fail. And then subgroup size, if the subgroup size is same, then you just enter the number. You say how many? 150. Okay. So the other is very similar to the other control chart that we learned before. So you have the option P chart option. So proportion P, if you know the P, you can put the value there. If you don't know, then just let it. Then these are the use the following subgroup. So I think this is for estimation. I think we no need to change anything, just follow exactly. Then the limit here. Okay, normally we are based on plus and minus 3 sigma. So if you want to see for a new control limit, sigma additional, so you can put here. If you want to see 2, then you put 2 here. Then the test is the same. You can have we only have a 3 sigma. Then these are the other optional or extra tests to detect out of control. If you want, you can try it also. Then display, then that's all. Storage. Okay, you want to show in the sheet here. These are the value you want to know. Then you just click there. Okay. So then I click them. It will show for me the central line and then control limit lower and upper. They are giving. So they are the same because I put the sample size 150, right? Which is the constant sample size. So they are the same. Central line also all are the same value. Where is the chart? I can find it. Here. So these are the P chart. Okay, so if I add in 2, then it will come out with plus and minus 2. Otherwise, the standard one will be 3 sigma here based on the upper and lower controlling. Okay, so if you look at here, plus and minus 2 sigma, it will be 1 point out of control. While if we use a standard 3 sigma, everything is okay. And after that, I try again, but now the P chart is different sample size, which is determined by expect column 2. So column 2 is the sample size which are different. So from here, you can see this is the variable sample size. So different sample size. And these are based on 2 sigma. Again, there's 1 point above. Okay, so if you look here, sample size different. The upper and lower control limit also show different value. Okay, so this is P chart. Next, you can use the same data to calculate or construct other type chart. So again, we want to do NP chart. Okay, so just now, I don't want to do the storage. Remove already. Okay. So same if I have a fixed sample size, I just enter the value here. Otherwise, you enter the column that show the sample size, which are different. And the other term are basically more or less the same as before. Okay, for data here, same with the other type of flow chart, even for the X bar and out chart. So if you detect any out of control, you want to remove them, then you remove. You can click here, specify which row to exclude. Then you enter the row number that you want to exclude it. And then this will be your revised control chart. Okay, so you can mention which observation, number 4 and number 8, for example. Then it's okay, so you can do so. So now we just have input everything. Number is okay. So overall, so we include overall. So your NP chart is here. Okay. All are in control. Okay. Then you can also do for other type of control chart. U chart. U chart. Again, for U chart, it can also consider for a constant or a variable sample size. Then you can put here. So the other option are more or less the same. So I don't consider anything. Okay, so this is U chart. All are same in control. Okay, then I can do for C chart. So for C chart, n equal to 1. So it does not provide the option to enter the sample size here. It's understood. Okay, C chart option is also very similar. Very similar. So you can try different type of test. Okay, let's say I select all. So yeah, there is no out control. So from here it does not list out any. So we consider many other tests also could not detect any out control. So it does not provide any summary. Otherwise, if there is out control, it will mention here. So all look fine. So there is no out control. This is this. see, do I have the assistant can do anything? Check. Yes, okay. Here also I have for assistant here. I have P U chat. So no, okay. Maybe I can try with P chat. So for P chat, number of defective is 12. And then how are your subgroup defined? So either okay, I have a column of because they are different size. Simple inspect. So how will you determine the control limits? So you want to estimate from the data or use an unknown value. If you click use unknown value, you need to enter the value here. Otherwise, I just will estimate because I don't have. Okay, so this is what I get. So it provides more option from here. This is the P chart summary report. So it give you the comment. Here you can add in, you want to edit also you can edit it. Then here it provide the stability report. So it provides some stability report, the summary here. So actually it provides some summary for you already. So you can use this as your conclusion. Okay. So assistant, control chart, U chart. We'll say with the U chart here. Instant line again. Here also I estimate, I don't know. Okay. Again, it give me different report. This is a summary report. So you can see more detail. So number of subgroup and so on. Then this is the stability report. So it say it has exhibit any type of the pattern here, then stability is not good. So it provide some explanation. If you have a global trend, what is the meaning? Okay. How is that very bad? So it explain to you all of them. So I think this is a good summary. And then for this one, because it does not show any pattern as defined here, so stability is good, no issue. Okay, I think I have covered everything. Okay. Any other thing you want to ask? Maybe I have a little bit forward here. Okay. Non-conformity classification. So how you classify the non-conformity? We can explain based on either it is critical, major, or minor. Critical, of course, you have a very severe or serious conformity problem. So it say that critical conformity is unsafe conditions for individual using, maintaining, or depending upon the product. So the condition is very bad, unsafe. For the major non-conformity result in failure or reduce materially the usability of the product for its intended purposes. So you can use it, but it will come up with some error or failure from time to time. While for the critical case, you cannot use it because the product may be not safe for use. For the minor conformities, reduce materially the usability of the product for its intended purposes. So you have a small mistake only, so this is still acceptable. So this is a guideline how to choose for the proper type of the control chart. Okay, so this is for S bar R or S bar S chart. So when you have to use it, so these are the conditions that suitable for the use of S bar and R. A new process is coming on the stream, or a new product is being manufactured by an existing process. The process has been in operation for some time, but it is chronically in trouble or unable to hold the specified tolerances. The process is in trouble and the control chart can be useful for diagnostic purposes. Disruptive testing or other expensive testing procedure is required. It is desirable to produce acceptance sampling or other downstream testing to a minimum when the process can be operated in control. Then attributes control charts have been used, but the process is either out of control or in control, but the yield is unacceptable. Okay, then meaning that you apply the attribute control chart, but it does not give you a good decision. Then there are very tight specification overlapping assembly tolerances or other difficult manufacturing problems. The operator must decide whether or not to adjust the process or when a setup must be evaluated. A change in the specification is the process in the level of the condition. Then these are the conditions to apply attribute charts. So operator control the assignable process, and it is necessary to reduce the process fallout. The process is a complex assembly operation, and product quality is measured in terms of the occurrence of non-conformity, successful or unsuccessful was necessary, but not this one I mentioned. So this is control chart for individual. So individual means it can be individual chart. So this one is based on the two types together, like S bar and R, S bar and S. Individual means you only have S bar chart or R chart individually. Okay, so these are the conditions. So just for your guideline only. But of course, different industry might have different condition. Is case by case. How to say? This is just for general references. Okay, I think I already cover everything. Okay. So far, any questions? So yeah. So this is very simple for the attribute control chart, and tomorrow we will move on to the historical data or the time historical control chart, which will consider the historical data. Okay? So in what we have learned about the attribute and variable control chart, both do not apply the historical data. Therefore, they have some limitation in which they are slow to detect the small out of control. While for the historical data control chart, they use the historical data of the past information. Therefore, they are more effective to signal or detect the out of control with a small shift. Okay, so there are three types of them, which we will discuss tomorrow. So if you do not have any question, then we can end the section today, and we meet again tomorrow at the same time. So have a nice day.